Yeah, so we're talking about working with headless content management systems today. Again, my name is Jared Scott. I'm the founder of Variable. I'm an interaction designer by trade, software engineer. I was the director of software, or not software, I was the director of front-end engineering at Convertro for 7 years. And now I'm running this group, readme Taiwan. The idea here is basically to just give people a chance to kind of learn about new and upcoming stuff, and it's also for me in the way that I'm just sharing things as I'm learning them. So hopefully more people in the future decide to come up here and do this. I don't want to be the only one every month. So let's just dive into it. So what is a CMS? Just content management system. Originally these date back usually to the early 2000s, or even before if you're talking about enterprise relationship systems. Typically, they're data plus schema. You have a front end that was intrinsically tied. A lot of good examples of these are Drupal, WordPress, Django, Ruby on Rails. The idea was that over any custom solution, a content management system gave someone the ability to have an abstraction layer on top of their database where they could add business logic easily that was completely separate, and be able to take the relations that they're defining in their, typically in RDBMS, and put some flavor on top of that. So what has changed? Why is this not kind of the preferred method nowadays? Why are people moving away from it? Well, one of the things that people have noticed is that you have two distinct systems, at least nowadays, and this comes with the advent of single-page applications, really rich front-end experiences, especially with React, Vue.js, stuff like that. You're basically having a front end and a back end, which are in of themselves are their own applications. So it makes sense from a development perspective, especially when you have specialized teams, to split those apart. You can have the front end developers not even have to care about learning Python, Java, some of these other languages, and you can have your UX designers, etc., not have to worry about builds breaking because someone forgot to migrate the database correctly. So that's where we've seen headless kind of coming about for the last 4 or 5 years. The idea here is that there's no front end coupled to the CMS itself. We're just talking base business logic, data, and usually an API. So this can be a RESTful API. More often than not nowadays, you're seeing a GraphQL-based API. And some of the reasons for that is GraphQL is considered like native web first. It follows JSON format, which makes it extremely simple to just integrate directly into a front end for a consumer. Some examples of these include Graph CMS, Strapi, WordPress, Headless. Strapi is what I'm going to be focusing on today, but I am going to talk about some other ones. So in this day and age, we've seen an explosion of these headless CMSs like just coming about. I'm going to share some. I'll have these links available later. So right now, there's over 24 headless CMSs out there, and this is just one compiled list. And this doesn't even include Strapi, WordPress, or any of the other legacy content management systems. And the reason I bring those up is because if you wanted to take a legacy system, a legacy content management system that you already have, and make it headless, it's very easy to do. As long as you have an API that is exposed on your CMS, you can easily just have some application that you've written point to it, consume that data, and then that can act as your new front end. Some reasons you don't really see that today is, if we go back a few years, interfaces, especially API interfaces, were not very, they weren't very standardized. Even REST which is, in of itself is a good kind of architecture mindset, it is not as standard. REST is just a way of, hey, this is what you should think about doing. So if you want something to be REST compliant, it's actually very easy to do. But if you want something to be fully standardized and what they would call like REST version 4, that's very difficult. REST version 4, just as a side note, is where you're making use of HTTP methods or HTTP verbs, and all of the data is interlinked together. So you can go from a root node and you can traverse the entire API. And the reason why that is important is because if you are a consumer and you have no idea what this API exposes, if you can traverse it just by following the links, then you can know everything that is available on the system. And even if it's poorly documented, you can kind of piece it together. GraphQL, in a way, solves this because that is what it does intrinsically. Everything is connected. The documentation is part and part with the schema. You can easily traverse nodes. I can give you an example of what GraphQL traversal looks like. This is based, and I'll blow this up. Give me a second. Figure out, grab it. There we go. I can do this. All right. So this is an example of GraphQL syntax. So somewhere in my system, I have something called events. And basically what we do is we give it kind of a pseudo JSON-like expression. And the idea is that I'm telling it exactly what I want. So GraphQL is very specific. You have to tell it what you want. You can't just do select star. Or at least you can't do. You always have to give a where clause in this case. This is what this is meaning. So you always have to tell what columns you want. That would be the relational way of thinking about it. So I have an event. This event exposes a number of things, but the ones that I'm interested in are the time location, the location link, which is basically where you go to click on it, and the topics that are going to be talked at that event. And then the topic is a nested relation. And for that, I care about the title description. I also care about the speaker, so I want his name. And then I want to be able to know how I can follow this guy, so I want to grab his social media links. So this right here is what I'm doing here. This is actually backed by Postgres. You can use MySQL or any other RDBMS or even a document relation store to do this. It works really good with MongoDB. The idea, though, is that it doesn't matter if it's relational or not. The GraphQL just cares about what data you want. So behind the scenes, no matter what you're using, it'll interpret what you're trying to do here. If it's like a Postgres database, it'll take this, write it into SQL syntax, run the query. So what is it that we get back? Well, we get a data. It's always prepended by data, unless you call it something else. So we get a list of events. We get the time, location link for each one, and then we get the associated topics, and then we get the associated speaker, and that speaker's associated social media links. So GraphQL is very powerful when using with kind of the web, single-page applications. If you're using React, if you're using even like something like Handlebars.js, a lot of templating systems that are in use today make it very easy to just give a JavaScript object or a JSON-like object into the page for it to render into using the shadow DOM and just populate automatically. So this is a very very powerful tool that people can use. So this is one of the reasons why headless content management systems have kind of they've gotten a lot of they've gotten pushed lately. So you have all these technologies like GraphQL, React, Vue for doing shadow DOMs, you have a lot of build tooling like Docker that makes it just dead simple to get things up and going. Just a lot of useful tools out in the community which make it very easy to separate these two. So you're seeing kind of a move away from what people would call a monolithic development style, where you have your backend and frontend together and your database, everything's deployed on one service. You're starting to see those kind of split apart. And there are good things and bad things about that. A lot of the times, especially for smaller shops, if you're if you're not doing too much, like following this paradigm doesn't make so much sense. This makes a lot of sense, especially in the cases where you need scalability. If you have an enterprise environment where you're getting your backend is getting hammered all the time, well, you're going to want to scale that out. That doesn't necessarily mean that you need a front end that has to scale to the same amount. With single page applications, you can front load a lot of the data onto a user's computer using local storage, session storage, etc. So you can usually make do with, even in high performance systems, you can make do with only running a few instances of your front end, and then just having an array of backends that hit up to the API, and then hit off either cache data locally on themselves, or even hit the backend data services. And using things like AWS, you can even take your CMS, your relations, and you can break them apart. So if, for instance, you have like an image service, you're in your Instagram or something, and a lot of what you do is media based. You can actually, for anything that is a media query, you can take that and using application load balancing, you can take anything that uses the media subquery and route it to its own preferred database, so that you can build that out into its own section of load balanced servers. So there's a lot of really cool stuff that's going on in the community as we speak. So what I want to do is show you what I've done. So there's a few headless CMSs that are really getting a lot of attention today. One of them is called GatsbyJS. Spell it right, or just click on the link. So GatsbyJS is it's a very nice product, but again, it's a product. So this is a SaaS solution, and it's a price model. And unfortunately, a lot of headless CMSs are set up this way, where they'll actually handle all of the they'll handle the entire backend for you. You don't even have to deploy it or do anything, and that can be really great if you have a client. You just need to spin something up for them. But the problem is the client has to be willing to take on a monthly based fee, because these are, unfortunately, they're per project per month. So that can be for some people that can be untenable. It really depends on how you explain it to your customers. A lot of times you can explain it in the sense that even if you co-located this yourself, had your own server instance, either running on AWS or locally, you're still going to be paying some sort of fee. If it's located locally in-house, you're going to be paying electricity to run it, which honestly, for whatever you're doing, if it's smaller service, probably not that much. You're probably talking a couple dollars. But if you're talking to AWS for a medium-sized company to run headless CMS, you're probably looking about roughly the same cost for just the headless CMS. Especially if you're spinning up some EC2 instance. If you're using something like AWS Fargate, or some of their serverless architecture, it could be less or more depending on the traffic that you're seeing. But the good thing about using some of those, AWS or some of these cloud-based solutions is they come with support built in. They come with uptime guarantees, and they come with scalability. If you're running something locally, that it's much harder for you to take that to scale if you're starting to get bumps in traffic. However, if you have everything Dockerized, etc., I don't think this does have an enterprise, but I don't know if it allows for. I don't know if they allow for an internal installation. So yeah, Graph CMS though, it's very nice, very intuitive. They have the ability to do pretty much anything that you'd want with typical CMS. You can build out your schema, you can build out your content, you can set up relations. It comes built in with different fields that you would expect: string fields, markdown enabled fields, floats, checkbox states. Pretty much everything that you've come to know and love. And it also has, I believe. I'm actually not sure because I didn't dive too deep into it. I did set it up myself, and you can as well. It has a free link. Actually, I can just log in. Totally forgot. I'm not sure exactly how you would go about building out your own business logic using this, since it's a hosted solution. But I'm assuming that there's a way to do it. Otherwise, it would be a little bit limited in what it allows. Sorry about my projector here, since colors are a little muted. But yeah, so here you can see messing around with models. You can build them out. You can create enumerations, they're a special type of field, which basically it's what it is. It's an enum field. You can have asset fields, so you can allow people to upload images. It also allows for webhooks, and it has an API Explorer, which is basically just GraphQL, which is exactly what I was showing you here. So this is a good, if you want to play around with headless CMSs today, this is a good thing to look into. It really gives you an idea of pretty much what everything in the marketplace is doing right now. So the next one I wanted to talk about is Strapi. And Strapi is, for all intents and purposes, is basically what I just showed you with Graph CMS, except it's open source, and you can manage your own content, your own plugins, your own business logic, and you can distribute it yourself. So you can host it.
What's the cost on that one?
Free.
Free. Okay.
Yeah, it's open source. So this is what I've been using and playing around with. They have a pretty strong community and growing. They also, it's built on Node. It's very, from what I can see so far, it's very stable. It does have some things that I find that I don't like. For instance, when you build out, go through it real quick, I'll show you. So they provide an admin, just like what Graph CMS does, and it gives you control of permissions, users. It has, I think, permission-based access control, which is nice. You can also, you have full control over how you want your content types exposed to the API. So if you have some kind of internal use content types which feed into the other ones, you can mark those as internal or private. You can you can build out documentation for your API. You can do the same things with images or files, etc. They have a plugin system, and for instance, you can add GraphQL, which I did, and you can even send emails through it. The marketplace isn't so big right now. Everything's been developed in-house that is there. What makes Strapi cool is you can build out your business logic layer more to your liking. So if there's some specific things that you want to do, like let's say you're doing a put or an update to speakers, and you need whatever change you're making to that speaker also something needs to flow to its related items, then you can customize that and add that into the code base and then commit it up and have it available.
Sorry, is business logic like like content types and Drupal?
No, business. So when I'm talking about business logic, what I'm talking about is what you've written in code, which sits between the front end and the database. So the business logic is like I have this item, I'm accessing it, but I have to do some sort of transformation to it. I have to grab more data. I have to when I touch it, I have to delete something else. They're additional things that need to happen while you're interacting with those objects. So, for example, if you're building out a shopping cart, business logic would include keeping state. So if you're moving through the cart, you need to keep that state, and you have the business logic would be like if I click on an add button, I go and I add something else to the cart. I'm not necessarily updating anything in the backend yet, but I'm holding this state, and so some developer has to have written that code to be able to manage that process, and that's typically what business logic refers to. If you're thinking of MVC, it would be the C.
Oh, yeah.
That's typically what it refers to.
Okay.
So you can build out your own business logic, commit it up, which is great. The one thing I don't like about it though is that the content types and everything that you do is all the state is held within JSON files. So what that means is that if you are doing, you can't do any build out of your content types on production, because what ends up happening is that, well, you could, but I wouldn't suggest it because you might lose, if your server goes down or something happens, you'll lose all that information. Typically, what you would want to do is use what I would tend to do for content types is store that information in a database. But what Strapi does is it stores it in JSON files. So what you can do is when you're developing on your local computer, you also are developing your content types that you want. Those get saved into JSON files, which you can then commit into your versioning system and then push out. And typically, if you have like a CI/CD process set up, then your CI/CD will grab those changes, run the build, and then deploy it to your production service. Once it's deployed, then you have access to the content types. It makes sense in that regard, but it also means that you can't make any, like if you need to do some changes, you won't be able to make those on production. There's good and bad things about that. The good thing is that hopefully that means that you won't be able to get out of sync with your development. But it also means that if you need to make quick changes, you really can. So pluses and minuses. In the end, it might actually be a good thing, especially if you're working with clients who have no idea what it is. You don't want them touching that stuff. You don't want them, you know, it's great that they would lock the content types down, because if someone deletes one, then they're screwed. Let's see. So what I've done here is, let me just show you. So the example I'm using here is based off of my website that I wrote for this meetup, and this latest one is wrong. So I haven't hooked up Strapi as my backend to feed information yet, but when it does, what I'll be using it for is populating this information, and then also populating the past events. So the idea is that I can have this front end and have no stateful information that's held within the front end itself. It goes off, it accesses an API, pulls that information in, and then makes use of it. The other thing that's really cool about this website is that this is a static website, in the sense that all this data that you're seeing right now was built at build time. So this is called this was built using GatsbyJS. So GatsbyJS is it's a React-based static site generator. What's really cool about it is that since it is React, you can, like, they call it a static site generator, but it's all React, so it can be as dynamic as you want. It just has these additional things that are built in that make it highly performant. So one way to think of what GatsbyJS makes, like, what makes it really interesting would be, let's think about it like an email inbox. So if we go, I don't want to show you my email, but if you're thinking about Gmail and what Gmail does, when on load, Gmail has to populate with the latest 10 or 20 messages. What GatsbyJS does is, let's say you're developing the Gmail app on GatsbyJS. What you do is that you tell the service that you want it to pull. Let's see, I can pull up the code so we can kind of talk through it. Let's go to the go to something that shows. That's a good one. Okay. So, you need, yeah, no, I was looking around first. Okay, so Gatsby has this thing where when you're, so this is actually in this is I guess you'd call it the view file or the template file. So this is in a file called datetime.js, and what this does is this basically outputs this here. And I also reuse it in a few different places. So I wrote it as a component. Components in React basically are just reusable snippets of template files where you can mix and match and use them wherever you need to. So in this component basically just grabs the current datetime and prints it out. So what you see here is you see a little snippet query. And this is called the static query. So what this means is that when I go to build my GatsbyJS site to compile the static files, when it's doing that, it'll go off, it'll run this query and get the current value of that, and then populate it into this render into the data. So it'll populate the Unix time at build time, not render time. So that's the difference here. So that's what is typically a static site. Static site is when all the data is pulled in at build time, And then when you actually load the page, it's not making any AJAX queries. It's not doing anything in the backend really. It's just showing you what it knows. So it doesn't seem very powerful, but it is in the case where if we look at the past events page, for example, typically you're not building and releasing these every day. So let's imagine I have an event that occurs every day, and you can write it originally where it just has this query where it goes and it gets the past events, whatever, and displays it on that page. But the problem is if that's all you're doing, unless you're rebuilding your code every day, it's going to quickly get out of sync because, again, these are only interpreted at build time. But since this is running React and it's JavaScript, everything, what you can do is you can just add a little snippet, which would basically, on render time, when someone loads the page, it'll query the exact same thing for any modifications or any updates, and it'll pull those in on top of what it already has. So imagine you have another field like updated time, or even just the ID. If you put the ID in here, and if you know the ID is sequential, then when you're writing your little JavaScript snippet, you just say, grab the past events that have occurred since this ID, and then you just append it to this list of data, and then boom. So anytime someone refreshes this page, you have not only the ones that it had at build time, but then you have everything else that happened after that. So you can actually make these sites have that interactivity. So if you're doing like a Gmail app, you can have it, instantly load messages and then just add more messages as they come in. So it's a very nice way of getting the performance benefits of a static site, because a lot of these things you don't change every day. I mean, this might change daily, but the sponsorship links, the about us information, pretty much everything else. I don't need it to be.
Don't have to worry about it.
I don't have to. Why should I have to go to the server every time to get those templates if they're basically always the same? So, if you use something like this, you can get the benefit of that, super fast response time.
And avoid the database.
Yeah, well, you're doing a lot of things here. Like by doing this method, a static site, if you think of it from a cost, speed is huge, but even from a cost center perspective, you're saving a crap ton of money because a lot of this can even just be cached on the local user's computer. So you can reduce the amount of back and forth data charges that you're receiving. You can optimize performance and something like this can scale to hundreds of thousands, if not millions of people with no problem, because I'm using, in this case, I'm using CloudFront on AWS. Everything's cached on that side, and it distributes within milliseconds to anywhere that I care about. It's a very nice process, and from a development perspective, this is all React. You can get a kind of WYSIWYG style editing experience where you can make changes in your code and see those changes update automatically. You can easily mock out data because, again, if it's GraphQL, it's literally just you can back it with JSON, so you can create fixtures that make it super easy to test out your front end. Writing unit tests for all of this is dead simple. it's a huge community. So the other thing is that GatsbyJS allows you to pull data from all sorts of APIs. GraphQL works really well, but you can also pull from just Postgres databases, any RDBMS. You can easily build out what they call source plugins, which allow you to pull data from pretty much anywhere. You can easily write what they call a third-party GraphQL API, where basically you just tell it okay, what's the name that I want to call it when I'm typing it in, and where's the URL for the API, and it's that simple. If you are, let's see, they have a huge list of sourcing content. So you can source from the file system, which is what I'm doing right now. I just have a JSON file. I just have a simple JSON file where I have all my events that I just handle at the moment, which is getting migrated to the Headless CMS. You can have it pull from databases. You can pull from random SaaS services. GitHub has a GraphQL API. You can easily pull from there. You can source from WordPress, Drupal, Contentful, pretty much anything you can think of. And Strapi has a plugin too for their stuff, which you don't even really need to use, because since Strapi has GraphQL, you can just reach it at its API endpoint using the GraphQL plugin and easily get access to your data. So they work well together. Oh, the other thing about Strapi is it allows for localization. So you can have English, you can have Chinese, etc. You can build out your own languages. And yeah, so it's a very powerful paradigm, using a headless CMS with a statically generated site. Whether you choose to go with something like Gatsby or some other option that's available, it's super fast to develop. It's easy to containerize these services, and they have large, stable communities, and they're also very kind of forward-thinking. So they're all using, from a development perspective, it's very nice and fun and interesting to use these technologies, because they're quasi forefront. I mean, they're stable now, which is great. I don't like to be bleeding edge, but I like to be close enough that I can feel that excitement, and I don't feel like I'm stuck in 2004.
It's just China.
Yeah,
That's
exactly.
You have to target websites in China. They often have problems with.
Well, you're going to have problems for many reasons. Not, I would say least of all the fact that you're using. The least of all is the fact that they have a browser. They use browsers that are much older in some cases, especially in business applications, but also because just getting your content into China can be very difficult and painful. I had a few customers I was looking at who were based in China, and just from a development perspective, if I wanted to develop for that market, or if I needed to go there to work, to be on site, you wouldn't be even able to access your tools. AWS does have a China-specific region now, but it's completely separate from global AWS services, and you have to I think have like a Chinese registered ID to even use it. But don't quote me on that. You have to look that up.
Seems actually from our clients, they seem to be better than that. host it in Hong Kong, they can't host it in China. They seem to do better than Singapore, like for Baidu.
Yeah,
Which is,
and you know, they do have, like, they have their own parallel. They have a lot of like parallel resources available. So Google Analytics, there's Baidu Analytics. If you know you're any service that you're looking for, you know, abroad, you can typically find a variant in China.
Analytics does work.
Yeah.
It does work.
They're just not, they're not fun to work with because they tend to be janky, and you know, they're kind of like it's the case where you see something and you copy what you see, but you don't know what's in the back end. So like you get the gist of it, but you're missing a lot of like the finesse that makes some of these systems so performant or so powerful.
And it's not like bilingual or multilingual, so
No.
that's
Yeah. Yep. So that's pretty much what I wanted to share today. So I will be posting just some of this, and I'll post the video later.